Okay, good day everybody. It has been a while. Today I'll be talking on equation of a straight line. A straight line, this is a straight line, this is a straight line, this is a straight line. How does this straight line? Do they have equations? In a graph. Now everything just boils down to a graph. This topic will help you to understand how to plot a graph. I'll not be doing on the basics on this video. So this has to be like a graph has two components, the horizontal and the vertical components. So I'm going to tell you which one is the horizontal and which one is the vertical component. This point here is the horizontal, which is also called the x-axis, the positive x-axis. This is the vertical component, which is also the positive y-axis. For you to get a straight line graph, let's say I have a point here, let's call it y1. I have a point here, let's call it x1, and they meet. So this is a point. And let me say I have another point here, let's call it y2. I have another point somewhere here, let's call it x2. Sorry, it's not perfect. And this is another point. So this can be a straight line. As you can see, this is a straight line from the origin here. This is a straight line. I want to tell you things that can be brought out from this straight line. Now, if you can notice, this straight line has these two coordinates, point A and what? Point B. From here, I can see that here is point A is coordinates x1, y1. Point B is coordinates x2, y2. Now let's draw an imaginary line like this. It's an imaginary line. Let's draw an imaginary line. And here now will become 90. Let's say it's 90. Let me just name here a constant C, just like that, C. Now let me give you a little hint on something now. Now in this triangle, what do you notice now in this triangle? What do you notice in this triangle now? From here to here, if you notice, from here to here is like y2 is from this point to this point. Y2 is from here to here, and y1 is just from here to here. Look at this point. This point is just from here to here, which is just like saying y2 minus y1. Subtract y2 from y1. That is where you get this point. Then this point over here, from here to here, this is from here to here is x2, from here to here is x1. So this will just be x2 minus x1. Are you following me? And you have a common saying which says that gradient represented as m is equals to change in y all over change in x, which is simply now saying y2 minus y1 all over x2 minus x1. Is that not beautiful? This is beautiful. I've gotten a foundation about gradient. This is a very important thing to know about gradient. The next thing you should know is that if you look very well, let's say there's an angle here. There's an angle here, which is corresponding to this angle here. So there's an angle here. Let's say this is opposite adjacent hypotenuse. So I can say that tan theta is equals to y2 minus y1 all over opposite over adjacent. So you know your circle to opposite over adjacent. This is my opposite, this is my adjacent. So y2 minus y1 all over x2 minus x1, which is still equals to what? M. So that's why you hear the common saying that tan theta is equals to gradient. So we have a few more things to also know. Since you know this, you've gotten the foundation. What if they ask you in your question, find the distance between these coordinates A and B? What do you do? There is a formula for it. Distance between 2 points A and b is going to be equals to the square root of x2 minus x1 all square plus y2 minus y1 all square. Now if you look very well, this is a Pythagoras triangle. Let me just explain further for you. This is a Pythagoras triangle. I'm going to draw a triangle over here now. I'm just extracting it from this diagram. This is my A, if you notice, this is my B and this is my C. I say there is y2 minus y1. I say there is x2 minus x1. You know, yes, AB and this is 90. And you know from secondary school they say that the hypotenuse side square is equals to the opposite side square plus the adjacent side square. So AB square is equals to the opposite is this side here, which is y2 minus y1 all square plus the adjacent side square x2 minus x1 all square. So I don't want AB to have a square, so I have something like AB is equals to square root of y2 minus y1 all square plus x2 minus x1 all square. So we have basically dealt with the foundation of equation of a straight line.